distribution network. So this is very, very trending in today's world. So CDNs, the many vendors are there like Akamai, Limelight, and even the Google has its own CDN, content distribution network, because Google has various features like it has YouTube, and also search engines are there, and various other applications are there under the Google. So Google maintains a very important thing called as content distribution network. What is this CDN? The name itself tells. I hope now the video is visible. Sorry, the PPT screen is visible, right?
Yes, sir.
So it is a content distribution network. Means it is a network of content distribution servers. Content means anything, any content that needs to be distributed. For example, it may be videos or any multimedia data. So there are certain servers which gives the requested content to the user. The thing is, there is a word called as distribution. What is this distribution? So these servers are distributed at various locations of the world, and all these are connected. We call this as content distribution network. See, let us assume, say YouTube will take YouTube or a Netflix as an example now. See, there are actually in your textbook some case studies are there. You don't have that in syllabus. One case study on YouTube, another one is Netflix, and the third one is Kankan. So here I will be taking only Netflix. Okay, YouTube, we are all familiar with the YouTube, and Netflix is becoming popular nowadays. And the last one, Kankan is uh, kind of YouTube in China. Kankan is kind of YouTube in China. In China they don't support YouTube. They won't allow YouTube. So they have alternative to the YouTube, that is Kankan. Okay. I will be using these two terms. One is YouTube and another one is Netflix. I will take these two terms as example for the discussion. See here, uh, say so many videos are stored, millions of videos are stored in this YouTube and the Netflix servers. Now, user want to access them, access any one of those videos. So how to do that? How to do the streaming to hundreds? Whether only one user is trying to access that? No. Millions of users, thousands of users, lakhs of users will be sending a request to this YouTube or a Netflix server at a time. And these users are distributed in geographically. So I may be requesting from Bangalore, and some other person may be requesting from Delhi, and one more person at a time. So one more person is requesting from America, like that. So people are from different parts of the world, and they are requesting for a particular video from this YouTube or a Netflix servers. Now, how to stream this content to these millions of users who are distributed all over the world? So, one option is use a very big server. Let me call it as a data center. So, single server, a large server, and we can call it as a mega server or a data center. So, if it is a single server, definitely it is located at a single location. Imagine we are in the Bangalore, and suppose if this server is located at San Francisco in the US. Many of the servers are major servers are located in the US only. So if it is located there, so geographically, which is far for us, please understand, geographically which is far for us. So what are all the limitation of this approach using a single server? One of the limitation is single point of failure. Suddenly if something happens, if that server is not available for 5 minutes or 10 minutes also, even if it is for 5 minutes or 10 minutes, then it creates lot of impact. The entire world loses the connectivity with that particular server. We can't access it. ಒಂದು 5 ನಿಮಿಷ ಅದ್ರಲ್ಲಿ ಏನೋ ಪ್ರಾಬ್ಲಮ್ ಆದ್ರೂ, if it goes for maintenance, suppose if it faces some short circuit or something, then it create lot of problem. It is single point of failure. 5 ನಿಮಿಷಕ್ಕೆ ಪ್ರಾಬ್ಲಮ್ ಆಗುತ್ತೆ. Suppose if because of short circuit if the entire data is lost, imagine, then we lose all these contents. Data is very important, which is very, very precious in today's context. Now, another limitation. So when we have a single server, so there will be a only limited number of entry and exit point to these servers. When everyone starts sending the request, what happens? Is it possible to handle millions of requests which are getting generated per second or per millisecond like that? So it creates congestion. So it's not easy to handle so many requests at a time. So even if we adopt high-end devices there, so it becomes a congestion. ನಾನು ಎಷ್ಟು ಬಫರ್ ಹಾಕಿದ್ರು ಸಾಲಲ್ಲ ಅವಾಗ. And remember, they are the multimedia providers. Imagine the size of the multimedia data. Next, as I told, I am located in the Bangalore. If the server is at San Francisco or something, then it is geographically very far. So I need to take long path to reach the destination. So the contents at the server should pass through a long path in order to reach my device. So long path to the distant clients is one of the limitation. Next, through outgoing links, so it has to send multiple copies of the same video, because many people will be requesting for the same video. Again, because of that, it creates unnecessary redundant transmissions. So what we need to do, we should go for another approach. So distribute these servers. Don't maintain only one server. Maintain the similar content in so many servers, and don't place that in a single location. Distribute it geographically all over the world. ಎಲ್ಲೆಲ್ಲಿ ಸಾಧ್ಯನೋ ಅಲ್ಲಲ್ಲಿ maybe at least one server per continent, something like that. One server per one continent, something like that. So you distribute the servers. So we call this approach is called as content distribution networks. So all these servers maintain the same copy of the data. ಈಗ one server ಅಲ್ಲಿ ಏನಾದ್ರು change ಆಯ್ತು ಅಂದ್ರೆ, that should be suppose if any changes occurs in one server, that should be reflected in all the servers. So for that purpose, they are all connected. They form a network of servers which has contents. So these contents are distributed. So these servers are distributed geographically. So the limitations of the previous approach can be overcome through this approach. So first limitation was single point of failure. Suppose if the server which is there at California fails, then we have a server at the Singapore. Alternative server is there. It will take care of the load. Then the other thing is congestion. The load is distributed to a multiple servers. So the congestion won't occur here. So the load is distributed. Suppose instead of maintaining one server, if I maintain 10 server, the load is distributed. If 1000 requests are there, then 1000 divided by 10, so 100 requests will go to each server. So the congestion is avoided. So in the previous case, the single server should handle all the 1000 requests per second. But now that it is distributed, So 1000 divided by 10, so it is 100, 100, 100, 100, like that it get distributed. Next, geographically I can take a shorter path. Why I should send the data as a request to the server which is at the San Francisco, which is very far. So I can send it to a server which is there very nearer to me, like Singapore, like that. So usually this few servers are maintained in the Singapore also. That's why I'm taking these terms. So these are the common places of servers. Next, this other limitation is multiple copies of the videos. Redundant data can be avoided because it is distributed. There are two kinds of approach with respect to the CDN. One is enter deep and the another one is bring home. What is this enter deep? See, maintain so many copies of the server. See, for example, you take Akamai. Akamai is very famous. I hope many of you heard the term a company called Akamai. Akamai is a very popular content distribution server maintainers. For see, Netflix don't have their own CDNs. Netflix is a company, so they are relying on the vendor called Akamai. They have given a contract for to the Akamai for maintaining the servers. Netflix they don't have their own CDNs, but YouTube belongs to Google. Google has its own CDN. They have their own CDN. Netflix is a big video streamers, but they don't have their own CDNs. They have given a contract. Why they think in a other way? Why I should invest so much for maintaining this infrastructure? We have a very good vendor called Akamai and Limelight. Netflix has given contract to three people. One is Akamai, another one is Limelight, and the other one is Level 3. Okay, so they depend on them. They have given contract. They pay them for maintaining the servers. See, Akamai has maintained their servers at 1,700 locations in the world. Enter deep, we call it as. So spreaded across the world. So it won't create any problem with respect to fetching the video. So this is enter deep. Push CDN servers deep into many network, many access network. The other one is bring home. Just maintain only few things, few servers like 10 or something. So Limelight and even Google uses this approach, bring home approach. Only limited number of servers will be maintained. So how it operates, let us try to understand. So he is a Bob client. He want to request a video from a site called netcinema.com. So the URL for that particular video is like this. This is the URL. But NetCinema, just example, NetCinema is a company which has given the contract to a King CDN. Just example, terms ಅಷ್ಟೇ. ಇದು ನೆಟ್ಫ್ಲಿಕ್ಸ್ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, ಕಿಂಗ್ ಸಿಡಿಯನ್ ಬದಲು ಅಕಾಮೈ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. It has given the contract to King CDN. King CDN maintains all the videos in their server. Now how this works? First, Bob gets a URL for the video, and he sent a request for that particular URL. Open this anta keltane. So avaga that URL has to be reserved. So once he get to know the URL, so he has to contact his local DNS server whether you have IP address for netcinema.com with this URL. ನಿನ್ನ ಹತ್ರ IP address ಇದೆಯಾ ಅಂತ. ಅವಾಗ ಲೋಕಲ್ ಹೇಳ್ತಾನೆ, I don't have this IP address. I will send you the IP address of the NetCinema authoritative DNS. Now NetCinema authoritative DNS told that I don't have IP address for this because we have given the contract to other company. That company is King CDN. I will give their URL. You contact them. Now he will send a request to the DNS of the company called King CDM. So it gives the IP address. So it gave the IP address to this Bob. Now he will contact this particular company CDN and fetches the video and fetches the video. Now he starts watching that particular video. This is how your CDN works. Now, say, let us assume there are CDNs at 10 different locations in the world. One is at Singapore, one is at San Francisco, another one is in Australia, something like that. It is geographically distributed. Now the challenge is which one I should select. Can I always pick the server based on the geographical location? It may not work. See, Asia is a big continent. Suppose if Singapore maintains the server, so if so many people start sending a request to the same server, then Australia is a small continent, and where only few requests are there, the Singapore server is overloaded. Australian server has very less request. ಅದು ಆರಾಮಾಗಿರುತ್ತೆ ಬಟ್ ಇಲ್ಲಿ ಕಷ್ಟ ಆಗ್ತಿದೆ. So how to overcome this issue? So the first preference is pick the CDN based on geographical location. So if not only this case, we need to check whether it involves shorter delay or not. When delay is involved, so if it is more congested, then it involves too much of delay. So if it is less congested, then less delay will be there. And if we need to follow a long path, then we should avoid it. Like that, by looking into all these considerations, we need to select the proper CDN for streaming. There is one more approach, like Netflix uses this approach. This approach is used by Google, so YouTube. So picking the proper CDN based on geographical location, congestion level, and many other things. It depends on complete DNS itself. But in the Netflix, one of the approaches, it maintains different versions of video at various locations. First, the user fetches a manifesto file, so which is called as which has all the list of CDN servers. So based on the user preference, user will pick a proper CDN servers. It will decide whether I should contact the nearer one or the far away one, like that. So user will decide that.